Hello everybody, we're going to continue with our last video of trig review, and we're just going to continue looking at some more complex trig equations to solve. For this one here, we have cosine 2x minus cosine x equals 0, and we're looking to solve it on the interval 0 to 2 pi. Now the first thing is we're going to have to use an identity here, and if you don't remember your double angle identities, you can look at your IB formula sheet and you'll see that the cos 2 theta has 3 versions of identities. We're going to change it to this version. We're going to choose this one because we have another cosine theta in our expression. So we don't want to add in extra different kinds of ratios. So I'm going to replace cos 2x with 2 cos squared x minus 1. And I notice that I get what looks like a quadratic equation. Okay, if you can't see it right away, it might help if we rewrite the cosine x's with a's. If I replace cosine x with a, then I get 2a squared minus a minus 1. And that is something that I do know how to factor and is factorable. So I factor it and I set it equal to 0. And I see that either a equals negative 1/2 or a equals 1 to make the zero product property apply. The problem is the question asked me to solve for x, not for a, so I'm not done yet here. Okay, so if I start here, I'm going to replace that a back with cosine x. I'm going to say cosine x equals negative 1/2. I see that 1/2 and it makes me think of my special triangles. And in my special triangle, my pi over 6, pi over 2, pi over 3 triangle, I get 1/2 if I take this side over this side. This side is adjacent to pi over 3, which means that the angle, the reference angle that we care about is pi over 3. The fact that it's negative, we're going to take account for when we do our cast rule. So I need this reference angle, and I need to know that cosine is negative, so I can put my terminal arms in either the second quadrant or the third quadrant. Remember, all soup turns cold. So all ratios are positive here. Cosine's positive here, which means cosine is negative in quadrant 2 and quadrant 3. I place those reference angles between the terminal arm and the x-axis, okay, in both cases. And then the angle that I care about is this angle, starting at the initial arm on the positive x-axis and rotating to here. I get that if I can figure out what the value of x is if I take pi and subtract pi over 3, or if I take pi and add pi over 3. So those are two solutions to this equation. But this original equation also has a possible solution of cosine x equals 1. In this case, we're going to go to our toolbox for trig. We're not going to use a special triangle, but we can think about the graph. We know on the cosine x graph, cosine x equals 1 when x is 0 and when x is 2 pi. So we have 4 solutions to this equation. One last equation to look at. In this case, we have kind of a lot going on here. We're going to start by trying to get that x by itself. So we're going to divide both sides by 2. Okay, and I'm going to get sine of this big complicated thing is equal to negative root 3 over 2. Now that negative root 3 over 2 sounds like a special triangle, but this is a bit of a mess. So I'm going to let that mess equal a. Then I have something simpler. Sine a equals negative root 3 over 2. I can use my special triangle and think about, in my special triangle, root 3 over 2, this side is opposite from pi over 3. So that means that my reference angle alpha must be pi over 3. And sine is negative, so I need to think about 2 quadrants. Sine is negative in quadrant 3 and quadrant 4. So that pi over 3 either goes between the terminal arm and the x-axis here, or this terminal arm and the x-axis here. That means that angle A, the simplified angle, is either pi plus pi over 3 or 2 pi minus pi over 3. However, that's A, and I have to replace that back with the 2 times x minus pi over 3. Same thing over here, and then simplify and isolate for x, okay, which I've done here and here. Thank you, and we are done our trig review.